Welcome students of the ninth class, and here I am with the topic structure of the earth, which is the fourth lesson of your textbook. Before beginning with this lesson, let me give you an idea regarding what is continental drift. And it was 300 million years ago that the continents were joined together, forming a single landmass called Pangaea and a single sea known as Panthalassa. Continental drift was a theory that explained how continents shifted position on the Earth's surface. Now, this particular theory was set forth in 1912 by Alfred Wegener, a geophysicist and an astronomer. This theory was justified by the fact that similar kind of animals and plant fossils and even similar kind of rock formation are found in different continents. There are 6 large plates and about 12 to 15 smaller ones. All these plates resting on the lithosphere are continually on the move like giant rafts. It is on the asthenosphere that the plates of the continent and the ocean basins float, ride, rotate and underthrust each other. And this is how the continental drift continues till today. Now, based on this particular theory, let us begin with this chapter. Our planet Earth is more than 5,000 million years old and is still in the process of changing. In 1 year, the Atlantic Ocean widens by 10 centimeters, while the Pacific Ocean is shrinking as the continents move across the globe. The Red Sea is in its infancy. In 60 million years' time, it will be as wide as the Atlantic Ocean. Africa and Asia may split apart as a result of the Mediterranean merging with the Atlantic Ocean. So, in 1 year, we find the Atlantic Ocean widens by 10 centimeter. If you compare the size of Atlantic Ocean and the Pacific is much larger compared to the Atlantic Ocean. Now, there will be a time, another 60 million years from now, the Atlantic Ocean will be larger than the Pacific Ocean, and all the smaller water bodies which lie between Africa, Europe and Asia will merge with the Atlantic Ocean, and they will also form larger water bodies. So it is said that the Red Sea is now in infancy, but in 60 million years time it will be as wide as the Atlantic Ocean. Now, the layers of the Earth. The Earth comprises 3 main realms or regions: the lithosphere, which is the solid inorganic section, the hydrosphere, which is the liquid section, and finally the atmosphere or the gaseous section. So the Earth, we know, is made up of 3 regions or 3 domains: the lithosphere, which is the solid surface inorganic section, the hydrosphere, which is the liquid section, and the atmosphere, which envelops the Earth, which is the gaseous section. So before we begin with this chapter on the various layers of the Earth, let us first have a look at the diagram which is given in the adjacent page. Now, this particular diagram shows the interior structure of the Earth. The interior structure of the Earth can be compared to an apple. If you take an apple and you cut a vertical section of it right through the center of the apple, make it into 2 pieces, you will be able to see 3 distinct layers. The upper layer, which is actually the thin peel of the apple, the thickest layer, which is the fleshy part, and you find the center of the apple, which is where the seeds are contained. Okay, so we compare these 3 layers of the apple with the 3 layers of the Earth. The upper skin, which is called as the Earth's crust or the lithosphere. The fleshy part of the apple can be compared to the mantle, which is the thickest part, widest zone of the Earth. It is called as the mantle or the mesosphere. And the innermost part of the apple, where the seeds are contained, can be compared to the core of the Earth, and the core of the Earth is also termed as the Biosphere. So with this idea, let us begin with this the layers of the Earth. The thin outermost layer the Earth's crust averages about 17 kilometers in thickness throughout and is referred to as the mineral skin. Now, why is the Earth's crust referred to as the mineral skin? Is the reason why all the minerals which are available to mankind, to human being, is actually found in this particular layer. Different kinds of minerals are found in this particular layer, which is the crust of the earth. It is made up of continents and oceans, and from it emanates the soil, sediment, salt, gases, liquids, and all components of the earth in its widest connotations. And this particular the crust of the earth is made up of continents and oceans, and from this oceans and continents we have the different layers of soil, the sediments, the salt, the gases, the liquid, and all components of the earth which are found in its widest connotations. The crust of the earth consists basically of two types of rocks, granitic rocks and the basaltic rocks. Granite and basalt are the two basic types of rocks which form the crust of the earth. The composite zone inhabited by most living creatures is called as the biosphere. We have studied about this, children, in the first chapter itself. Of course, the first chapter, according to the revised syllabus which has been updated by the council, shows that the first chapter has been eliminated from your syllabus. Okay. So, the composite zone inhabited by most living creatures is called the biosphere. It includes a part of the atmosphere, the hydrosphere, and a part of the lithosphere. All three layers essential for life to exist. Remember, the biosphere is a zone which is formed by the combination of all the three spheres which are most essential for life to exist, the atmosphere, the lithosphere, and the hydrosphere. So, it is said that the biosphere exists a few kilometers above the earth's surface and a few kilometers below the earth's surface, where you find most of the life, different types of life existing. The earth is primarily made up of rocks, metals, and water. Its surface is solid, but its interior is composed of molten matter due to the intense heat it experiences. Now, it is said that as we go deeper and deeper into the earth, we will find that temperature increases and the density of the earth also keeps on increasing. Pressure also increases. So, with the increase in temperature, pressure as well as density, both of them keep on increasing as we penetrate deep into the earth. And at that particular temperature, it is really impossible for any matter to exist in the solid state, and therefore we find the interior is composed of molten matter due to the intense heat it experiences. The temperature within the earth increases with depth at the rate of 1 degree Celsius for every 32 meters depth, giving an average temperature of 5000 degrees Celsius at the center of the earth. In spite of its molten interior, the earth is firm and solid due to the great pressure of the lithosphere. So, we see the rate of change of temperature with the depth. It is 1 degree Celsius for every 32 meters of depth, and this would give rise to at least 5000 degrees Celsius at the center of the earth. And at this particular temperature, it is just not feasible for any matter to exist in a solid state, but we find the core of the earth to be in firm and solid state. How is that possible? It is due to the great pressure of the overlying rock that build up the mantle as well as the lithosphere of the earth. An idea of the interior structure of the earth has been obtained from a study of earthquake waves, and it is the seismologist seismography that has given an idea about the interior structure of the earth. Otherwise, it would be just impossible for any scientist to find out what are the different layers that make up the earth and what is its structure, what are the characteristic features of properties of each of these layers. It would be very difficult. It is because of this particular branch of science, that is seismology, that has given us a knowledge about the interior structure of the earth by the through the study of earthquake waves. The earth consists of three major concentric layers. These are called the crust, the mantle, and the core of the earth. The density, temperature, and pressure of these layers increase with depth. The chemical composition and physical state of matter inside the earth is of great concern for the study of landforms on the surface of the earth. The outermost layer, lithosphere or the crust of the earth, which consists of a thin layer with an average thickness of about 60 kilometers, forms less than 1% of the radius of the earth. So, when I began with the lesson, I told you children that you can compare the lithosphere or the crust of the earth to the skin of the apple. How thin is the skin of the apple? A very, very thin. Only 1% of it is taken up by the entire apple. Only 1% of the radius is made up by this lithosphere, which is just a covering on the earth's surface. The thickness, average thickness, is about 60 kilometers. Lithosphere or the earth's crust. The word lithosphere means rock sphere and is derived from the Latin word lithos, meaning rocks or stones. The earth's crust, averaging about 17 kilometers thick, the mineral skin as it is referred to, is the most significant part of the earth's surface. So, lithos is actually a Latin word which means rocks or stone. So, lithosphere means rock sphere. And in the lithosphere, 17 kilometers of this lithosphere is the mineral skin, which is the most significant part of the earth's surface. Why? Because it is very useful to mankind, because it consists of most of the minerals which are available to human beings for the industrial development, and therefore it has been referred to as the mineral skin. The crust is subdivided into two distinct parts according to its composition. Now the lithosphere of the crust again has been subdivided into two distinct parts, the Shear and the Sima. Okay, Shear is the uppermost layer. The topmost layer consists of granitic rocks, which on an average forms the first 25 kilometers of the crust and is lighter, having an average density of 2.7 grams per centimeter cube. This layer consists of silicates and aluminium and other lighter metals. This layer is called as Shear. Why? Because it has been derived from the two most abundantly found elements. Those are silica and aluminium. So, Shear, that is silicate, that is Si, and aluminium Al. The Shear layer is thick over the continents but is thin or absent on the ocean floor, especially the Pacific Ocean. So, here are the properties of the Shear which has been given, children. You will mark them point-wise. Number 1, Shear, it is the topmost layer. It consists basically of granitic rocks, and it has then number 2, it forms the first 25 kilometers of the crust and is lighter. Number 3, it has an average density of 2.7 grams per centimeter cube. And number 4, this layer consists of silicates and aluminium, and therefore it has been referred to as Shear. These are the letters forming the initials of these two elements which are found in abundance in this particular layer, that is silicates and aluminium. Then number 5, the Shear is thick over the continents but is thin or absent on the ocean floor, especially the Pacific Ocean. Now, the deepest ocean on the Earth's surface is the Pacific Ocean, and the Shear is a layer which makes up all the continent. And if the ocean floor is not very deep, then maybe there will be a thin layer of Shear present in the floor of the ocean. But ocean like Pacific Ocean, which is very, very deep, the Shear layer is absolutely absent. Now, below the Shear is the Sima. Below the Shear layer is a denser layer on an average 35 kilometers, which consists predominantly of silicates of magnesium, iron, and other denser metals. It is a continuous zone of basaltic rocks forming the ocean floors. This is called Sima, silicates and magnesium. Si, silicate, and Ma is magnesium layer. The Sima layer has an average density of about 3.0 grams per centimeter cube. So, we will take the properties again point-wise. Number 1, below the Shear layer is a denser layer which is called as Sima. Number 2, it has an average thickness of 35 kilometers. Number 3 consists predominantly of silicates of magnesium, iron and other denser metal, and therefore it is referred to as SIMA. This is called SIMA because Si silicate and Ma is magnesium layer. Number 5, it is a continuous zone of basaltic rocks forming the ocean floor. Mind it, SIMA is a layer which is present below the Ciel, and this layer is a layer which forms the floor of the ocean. It is made up of basically basaltic rocks. And the 5th point is the SIMA layer has an average density of about 3.0 grams per centimeter cube. So, we conclude today. Hope you all are keeping yourself tuned with the video classes. Take care, goodbye, and good luck.